All right, guys, making our way through surface area and volume.
Yep.
Right. Actually, we haven't even started talking about volume
No,
in
we
this
haven't.
chapter yet, but we'll
Lateral.
get there. Yeah.
For surface area, fun stuff.
And these are a little bit more difficult in this section. These aren't too bad. The
No.
the pyramids, because they're kind of like the prisms in a way. It's just that the sides are very different than the base, and there's only one base. But the next one that we look at, cones, those are very different. And so you guys got to make sure that you're up on this. You got to make sure that you're paying attention and understand the examples that we talk about, and make sure that you're staying up with homework for this section, because it's a bit of a tough one. So nothing new in terms of the concept.
Nope.
Still talking about surface area.
New vocabulary word though.
New vocabulary word. Regular pyramid.
Well, on slant height.
Oh, and slant height. That's true.
Yeah.
Yeah, we have to be careful with that. So a regular pyramid is what you would think of as a pyramid.
Yeah.
It has triangular sides, and it could have any number of them depending on what the base shape is. But they all come up to a point. So instead of there being a base and a base, and then the sides are perpendicular to all those and so on, they all come up to a point now for a pyramid. And so as we look at this formula here, the surface area is the area of the base. Remember, capital V is area of the base. And then we have to find the area of all those sides. And so basically the way to do that is looking at the sides being triangles. Normally that would be 1/2 the base times the height. And so instead we're going to do them all at once. So instead of using just one base and doing it however many times, we're going to add up all the bases, little b base. We're going to add up all the bases of the triangles together and make that the perimeter. And then we're going to use the height of those triangles, and as Mr. Padilla just said, that's kind of a new height. It's not the perpendicular height of the pyramid. Notice that it's not from the point of the pyramid straight down to the base, in the center of the base, perpendicular. It's what's called the slant height. And in all the formulas, and we use this in other shapes, in all the formulas it will be designated with a script L. And so that slant height is the perpendicular height to the base of one of the sides, of one of the lateral faces here. And so just notice where that L is in the diagram there. So we're going to take the perimeter of the base, multiply it by that slant height, which would be the height of one of the triangles on the sides, and then the 1/2 comes from the formula of the area of a triangle, because a triangle is half of a rectangle. All right? And so for the most part, this really will be just plugging into the formula.
Yeah, pretty much.
And so you just got to know what the pieces are, and that new piece is that slant height. All right?
One thing I would say to you guys is if you look at the yellow pyramid in there, they kind of do like a little triangle that's kind of like a cross section on the inside.
Right.
Just remember that some of the times, guys, you're going to see these where they're going to give you actually the perpendicular altitude of the pyramid, and then you're going to have to use Pythagorean theorem to figure out the slant height. So you just got to be careful that you don't just use any old height willy-nilly you want to use.
Right.
It's always got to be that slant height, and so, but they are going to try to get you and give you the altitude of the pyramid sometimes, and you got to know how to go back and find the slant height. So.
And notice we're talking about a regular pyramid, and so that black piece of that triangle that Mr. Bedell is talking about, the bottom of the triangle, base of that triangle, is always going to be half of the side length or the edge length of the base. And so even if they don't give you that, but they give you the side of the square or rectangle or whatever it is on the bottom, it's always half of that. For these types of shapes, I guess I should be careful there, because we are going to do some hexagonal pyramids and so on, and so that would be the apothem. And so, yeah, you're going to have to use Pythagorean's theorem to get there in order to find the red piece. The red piece is what we're talking about. That's the slant height.
Yep.
The blue piece is the altitude, or the height of the pyramid as a whole. So.
All right, so here we go.
Yeah.
As Mr. Scritch will just say, we got to find the surface area of this hexagonal pyramid here. So remember, we want to figure out, well, the formula, just to start off, is going to be the surface area of the hexagonal pyramid is going to be the area of the base plus 1/2 the perimeter of the base times the slant height. Okay, so you got to kind of change this up, because in order to find the area of the base, you've got to use the apothem times the perimeter to do that.
Yeah, you really have to picture pulling that base off of there. And
exactly.
We probably should have made it to where the slide had just a hexagon on it, because
right.
that base is a hexagon. So think about there being just a hexagon. Go back to section 7 of chapter 11, and you got to find the area of just that hexagon.
Right. So when you start doing this here, guys, in order to find the area of that base, you're going to have to go 1/2, okay, times the apothem, which is 5√3 there, times 60, which is the perimeter of the base. So you got to be really, really careful here. So, once again, look back at your formulas to find the area of a polygon like that, and it's 1/2 the apothem times the perimeter. Okay, and now all we got to do is figure out the slant height. Okay, or add it to our next piece here, which is now 1/2 the perimeter, so 1/2 of 60 again, because the perimeter around that hexagon on the bottom is 10 times 6, which is 60, and the 14 is the slant height there. It's off to the left in blue, and so all you got to do is plug that into your calculator and hit enter, and you'll get the answer of 150 root 3 plus 420 feet. Now you can't put those together because that radical 3 there, but if you just can go through and follow that through on your calculator, you get about approximately 679.8 feet squared. Now this is about as hard as they get when you have to do a surface area of some kind of a pyramid.
Right.
If so, don't think they're all going to be like this. We'll do some of these in class, but this is kind of how it would be if you were going to do a hexagonal prism. So, don't forget about 1/2 AP as far as 1/2 the apothem times the perimeter to give yourself the area of a hexagon.
Right. And don't forget what we're doing here. We're finding surface area. That's the
Yeah.
area of all the surfaces of this shape. And so it's still measured in square units, okay? And just realize in this particular example where the two 1/2s come from. The first one comes from the formula for the area of a regular hexagon or a regular polygon. The second 1/2 comes from this formula that we had down here, 1/2 PL. And so just make sure that you realize you're just plugging in the other pieces there now. And you have to find perimeter twice, basically.
Yeah.
That's why there's two 60s in there.
That's right.
So, all right. Okay, now this is the shape that's kind of different. A right cone, which we've all seen cones, an ice cream cone is a right cone. What we mean by a right cone is that the point of the cone is not kind of skewed off somewhere weird, but the point of the cone is at a right angle with the center of the circular base. And so the tip of the cone basically is in the center of that circle. And so notice where that slant height is now. That slant height is basically measuring from the tip out to the edge of the circular base there. Okay, and then because it is a circular base, you can kind of compare this to a cylinder. In order to find the area of that bottom of that base, you have to have the radius. And so this probably more than any other shapes, this is pretty much one of those you just have to plug into the formula.
Pretty much.
You may not understand the formula completely, but you just have to plug into the formula here. Okay? And so here's the formula for the surface area of a right cone, which really is the same formula. It's just circumference instead of perimeter.
Right.
And so, so it's still the same formula. S is equal to the area of the base plus 1/2 CL. Or, because we're in circles here, we're in the world of circles with these particular shapes, the area of the base is the area of a circle. Area of a circle is pi r squared. So that's where the pi r squared comes from there. The pi RL comes from the fact that the circumference is 2 pi r. Well, the 2 pi r and circumference cancels, the 2 in there cancels with the 1/2, so that's why the 1/2 is not there anymore. And then the pi r is what's left of the circumference times that slant height there. And I realize that they're using a capital L for slant height instead of the script L that they should be using, but L is L here, it's the slant height. Okay?
I think they had font issues.
Maybe so. Maybe they, I don't know. Maybe they couldn't find a font that would work with the script. So here's now don't let the fact that it's upside down throw you. It's still just a cone, and so we're finding the surface area. Okay, so we're finding the area of the circle, the base, and then we're finding the area of. Now this is why this doesn't work like compared to a cylinder, because if we unfold a cylinder, like take the label off a soup can, that's a rectangle. You unfold that and it's just some weird shape.
Yeah.
It'd be hard to find the surface area of that thing. So that's not why we're not talking about it that way. So find the surface area of this. It's a matter of just plugging into the S equals pi r squared plus pi RL. And so really all we need for that is two measurements, R and L. And they gave us two measurements here, but notice that the 8 is not the L. And so this kind of goes back to what Mr. Bedell was saying back in the pyramids, is that they may give you the perpendicular height, but that's not the height we need. We need the lateral height here. Okay? So you're going to have to use Pythagorean's theorem here. And if you know your perfect Pythagorean triples, if you know your 3, 4, 5s, this is just double a 3, 4, 5. It's 6, 8, 10. So that slant height is going to end up being 10 for this particular cone here. So if we start plugging into the formula, we get pi, the radius is 6, so pi times 6 squared, plus pi times 6 again, times that slant height. And we just found the slant height to be 10 from Pythagorean's theorem. And so we end up with a 36 pi at the beginning, 6 squared pi, and we end up with a 6 pi at the end, and 60 pi, I'm sorry, 6 times 10, so 60 pi. So we can add those together because they're both just pi's. And so the exact surface area of this is 96 pi square meters, because we're in meters for this one. Okay, if you're going to approximate that, then it would be approximately 301.6 square meters if you plug that into your calculator. Okay, so just like all the other sections, we're going to have more examples like this in class. We're going to have you do several of them in book assignments and worksheet assignments, and just really plugging into formulas. Once you know the formula and you find the pieces you need, it's just algebra. Just plug it in.
Yep.
So, okay, so we'll see you guys in class with examples of this type.